Hello everyone, welcome to this class. In this class we are going to continue our class on logarithm with tables, and we are going to deal with calculation of power and root. So let's solve example 50. Let's solve example 15. This example is simply for us to prove how we'll be solving this logarithm with power. When you have something like this, also now this is the same as 53.75 all raised to power 3. But because we are solving logarithm with table, we'll look for the logarithm of this. Let me say we look for logarithm of 53.75. So how do we go about it? Our normal, I don't know if I should be jumping step, but because I'm using table, I want to be showing it, so we'll be getting used to the tables part of it. So we have changing to standard for we have 53.75 times 10 raised to power 1. So my characteristics is 1. So I now look for 53 under 7 difference of 5 is anti-log table. So go to logarithm table. 53 under 7, that's 7300. Difference of 5, that is 4. So I have 73004. So you have 7304. So the logarithm is characteristics dot the mantissa. Now, when you get this, what does it mean? It means when you raise 10 to this power, you get that. So let's write it in indices form. 10 raised to power 1.304. And we're writing this all raised to power 3. Remember our law of indices. When you have x raised to power a or b outside, is the same as x raised to power a times b. So we now apply that law here. So this will be 10 raised to power 3 times 1.7304, which is equal to 10 raised to power 5.1912. And remember what I told you, solving this is the same thing as saying anti-logarithm of this. So we'll look for anti-log of 5.1912. So we'll leave the characteristics out and solve for the mantissa. So I'll look for dot 19 under 1 difference 2. Go to your anti-log table. Dot 19, this is 19 under 1. So this 19 under 1 is 1522. So I'll write it 15. Don't even know what I'm saying. 1552. So the difference is, what do you keep it? The difference is 2. So difference 2 is 1. So we add it. So it will be 1553. So to get your final answer, you now do 1.553 times 10 raised to power what? The mantissa, the characteristics, sorry, which will give you 1, 2, 3, 4, 5. 155,300. This is your answer. So the next thing you are going to do is to cross check if your answer is really correct by putting this inside your calculator. Just type 53.75 raised to power 3. Just type this in your calculator and let's see the answer we are going to get. So the answer we are going to get in this case, so for my calculator I'm getting 155,287. So you can see that the answers are almost the same. If you here now, let me say 1, 2, 3, 4. If you do it to 4 significant figure, that's 1, 2, 3, 4, so that you can now, here will be 3 and the rest will be 0. So the answer is very close. This is for the power. Let's solve for the root. So for the root, we have cube root of 350. So this, according to our law of indices, is the same as 350 raised to power 1 over 3, if we are not wrong. So the next thing we are going to do is find the logarithm of this. I will say log 350, change it to standard form. I'll have 3.5 times 10 raised to power 2, so my characteristics is 2. So the next thing we are going to do is look for the mantis and using the 4-figure table to simply be 35 under 0. 35 under 0. So I'll go to my anti-logarithm table. So go to your logarithm table. 35 under 0, which is 5441. So you have 5441. So my logarithm now will be characteristics dot the mantis, which is 2.5441 is my answer. Remember what we said. This is the same as 10 raised. This logarithm of 350 is what I go to raise 10 to the power to get 350. So I can rewrite this my equation as 10 raised to power 2.5441 or multiply by 1 over 3. Remember our law of indices, where you have x raised to power a, or in bracket times that, or in bracket raised to power 1a over b. This will give you something like x a over b. I don't forget. Remember our law of indices, when you have x raised to power a inside the bracket, all of them are raised to the power of fractional indices. We did this when we did a fractional indices. Check our playlist on fractional indices. You see where we solve for this. It simply means the power of x in the bracket divided by the power of this x outside the bracket. So simply we are going to, this will be the same as 10 raised to power 2.5441 divided by 3. So this will give us what? 2.5441 divided by 3 will give us 10 raised to power 0.8480. So looking for this is the same thing as finding the anti-logarithm of that. So we'll just simply do anti-log of 0.8480. So what we are going to do, these are characteristics, we are not touching it, just go for 84 under 8. This is logarithm, so we'll go to anti-log 84 under 8. This is 8. 7040. So I have 7040. So to now get the final answer, I will do, this is my what I get from the logarithm table. This, so I'll do 7.040 times 10 raised to power what? The characteristics. So the answer is still 0.040 times 10 raised to power 0. So the answer is 7.040. So this is your final answer to this evaluation. So the next thing we are going to do is to confirm if this answer is correct. We use our calculator and solve for this 350 to see what we get. So I'll leave you to solve for this to confirm that the answer is close to this, meaning that we got the same, that we are correct. Though I don't know, for a reason I don't know, this 84 under 8, because I cross-check, is 7047. For a reason I don't know, I put 7040. So this is wrong. The answer is 7047. Here is 7047, and for that reason here too will be 7047. So my real answer is 7047. These are some errors you see in these things. So confirm this with your calculator to confirm that you are getting the same answer. But there is another way you can solve for this. You can decide to, when you have this kind of answer, you can decide to just jump step. That's if you don't, because here we have to prove it. That's why I have to go through this step. This is what I think is the hardest exercise I can solve to summarize everything I've done in this class concerning the addition, concerning the multiplication, division, and power using logarithm with table. To make this class not to be too long, maybe we should not, okay, I'm thinking of jumping step of not using bringing in the table, but let's just jump steps. I believe at this point we all know how to solve this logarithm with table, so I'll just bring out the logarithm and we'll start solving. Maybe during the antilogarithm I can use the table back. So I've already solved the logarithms with table. I did not show it in this class to save time, so on your own you can decide to confirm all these logarithms. Now let's start applying our law of logarithm. This is that, so you can see all of them. First thing first, since I've converted all this number to logarithm, now we have log. I will replace this number to now be, remember our law for logarithm. Now I've converted to logarithm. This normal law will now apply again. We now use the normal laws of logarithm, so it will now be something like this. This times this will now be, this is equivalent 1.5834. When you are multiplying logarithm, what do? You add plus. This is now that 0.4719, or divided by what? 0.9364. Okay, it's still multiplication, Abby. Yeah, plus this 6 is that, so I'm replacing it 0.7983. So first thing first, we are solving what is inside first. We have not come to this power and this root, so at this point we are adding because it's multiplication. So this will give me, so when you add this you get that, when you add this you also get that. Now let's solve for this division sign, and according to our law of logarithm, when you have division, what do? You subtract. So it will be this 0.0553 minus the one under 1.7347, so I'll get 0.3206. So I've finished solving for what is inside the bracket. Are we together? So the next thing I'm going to solve for is the power and the root. Remember, all these are in log form, so we are going to apply the law of logarithm, indirectly law of indices. So the next thing is, when you have power, what does it mean? It means that you multiply. So you now have 0.3206. What power is there? Times 2. So what am I getting? Let me figure. This is stage 1. For stage 1, I just solve the numerator and denominator. Let me call this stage 2. For stage 2, I've solved the numerator and denominator. Now solve the division sign. Now stage 3, I'm solving the power. Stage 3. So this will give me what? So I'm getting 0.6412. Now final stage, which is my stage 4. I'm solving the root. From our law, what does root means? You divide by the root. Whatever that is here, you divide it. So it will be 0.6412 divided by 3. I'll have 0.2137. Now I've gotten this 0.2137. I've finished solving everything here. What is the next thing I'm going to do? I'll find the antilogarithm. See how simple it is. It's just for you to understand the concept of 0.2137. So our characteristics here is 0. We'll look for dot 21. Is our antilogarithm table. Dot 21 under 3 difference 7 under 3. 3 is 1633. So I have 1633. Difference of 7. Dot 21 under, confirming, under 3. Yeah. Difference of 7. 7 is 3. So when you add it, you have 1636. So find your final answer. It will be 1.636 times 10 raised to power what? The characteristic, which is 0. This is give you 1.636 as your final answer. So there are two ways you can confirm this. You can solve this with your calculator in a normal way to see what you get. I will not do that. Do that on your own, or you can just go to your answer sheet, exercise 1L number 50. As you can see, we got 1.636. So we got the answer correct. So hope we understand what we did here. This was given to us. The only thing is that I didn't show my working for the logarithm, so we'll save time in this class. I just went straight and solved it on my own and bring in the answer. If I'm to explain this with 10, you will have something like, if I'm to explain it with the law we used earlier, let's call this A, B, C, D. I'll have something like 10 raised to the power A times 10 raised to the power B, all divided by 10 raised to the power C times 10 raised to the power D, all squared, all root 3. If you are to apply a law of logarithm in this, this will turn to 10 raised to the power A plus B all over 10 raised to the power C plus D, which is the first thing we did, all what? Squared, all root 3, right? Next one will be 10 raised to the power A plus B minus C plus D. That's what we did here. All squared, all root 3, right? Next stage we are going to do is, when we solve for the square and for the root, it will be 10 raised to the power A plus B minus C plus D. Now when you open up this bracket, everything here will multiply by what? Times 2 times 1 over 3, which is the same thing we did here when we did times 2 divided by 3. You see it? So this is just to show that we are spot on. I can replace all these A, B, C, D with the values we have in the logarithm here, and when I solve it, you see that we are repeating exactly the same thing here. So this is summary of solving logarithm of number using base, or of numbers in base 10 using the table. Thank you. If you have any question, you can also ask in the comment section. See you in the next class.